Welcome back to this session. Today in this session we'll be solving shear force and bending moment diagram for again a overhanging beam. So let us get started. So for this first numerical, the diagram for the overhanging beam is given along with the loading. So let us see how we can find shear force and bending moment for such kind of overhanging beam loaded in this manner. Let us start by finding its reaction. So in this case I'll have reaction RB and at C, RC. So I'll have RB and RC. So the total reaction RB plus RC will be equal to total load coming on the beam. So the first load that I have is at A point, which is point load 2 kN plus UDL 3 into 6 plus point load 2 kN. So if we add up all of this, we will be getting equal to 18 kN. Okay. Now summation of moment about B equals to 0. Now I'm taking a reference point at B here. Okay. Now this load, point load from A will go in a anti-clockwise direction, in this direction towards B. तो कैसे होंगे? So first, to go from A to B, this distance is given equal to 1 meter. So to go from A to B, this load at point load at A will go in the anti-clockwise direction towards B. So anti-clockwise is negative, so minus 2 into the distance is 1 meter from A to B. Then I have plus RB into 0, क्योंकि B पे मेरा रेफरेंस पॉइंट है तो यहाँ पर शुरू हुआ है तो उसका डिस्टेंस 0 होगा. Okay. Then next I have a UDL coming. It will go in this direction towards B, which is a clockwise direction. और ये RB जो है, RC जो है, ये RC will go in an anti-clockwise direction, and similarly this point load will go in a clockwise direction. So let us see UDL in a clockwise direction. So plus 3 into the total distance is 6 into 6 by 2 minus RC into distance from C till B is 6, right? Then point load from D, which is going clockwise direction, so plus 2 into total distance from D to B is 7 meters, so equals to 0. Now if you solve this, here you will get minus 2. Then if you solve this one, you will get this one equal to 54. 2 into 7, 14, equals to, I'm sending this to right hand side direction, so it will be 6RC. Now from here, the total of this will be coming equal to 66, equal to 6RC. RC will be equal to 66 by 6, which will be equal to 11 kilonewton. Now from here, RA, ये equation से RA will be equal to 18 minus 11. This will be coming equal to, I'm sorry, the total of this force here will not be 18 kilonewton, it will be 22 kilonewton. So here it will be 22 minus 11, again 11 kilonewton. So this is not, it is RB. Okay. So RB here is coming equal to 11 kilonewton and RC is also coming 11 kilonewton. Now let's find shear force. Shear force calculation. So I have force at A, ये point पे. So remember, whatever force comes from top to bottom, it is minus, and which goes from bottom to top, it is plus, right? So at A, I have a force coming from top to bottom, so it is minus 2 kilonewton directly, right? So now let's find force at B. Force at B and left hand side of B. Left hand side bola to it will be this direction of B. So last force कितना मिला? minus 2 kilonewton. और A और B के बीच पे कोई force है? There is no force acting in between A and B, so it will remain minus 2 only. Now force at B, right hand side of B will be equal to minus 2. Last force we got minus 2. Now B के नीचे we have a reaction RB, which is coming from bottom to top. So bottom to top is plus. RB was equal to 11. So this will give you 9 kilonewton. Now similarly, let us find force at this point, E point. Okay, so E point is given here, so we need to find force at E also. So force at E, left hand side of E will be equal to, last force we got 9 up E pe, right? E ka left hand side is this direction. So we have UDL moving for a distance of 3 meter till E. So minus 3 into 3. So this is coming 0. So force at E is coming 0. Now let us find force at E and to the right hand side of E. Right hand side of E is this direction. So last force we got 0. Now अभी यहाँ पर फिर से दूसरा UDL शुरू हुआ है. So if I put that UDL 3 into, it has just started at this point E, so its distance is 0. So again I have 0 at force at E and to the right hand side direction. Now let us find force at C and to the left hand side of C. Left hand side of C is towards this E direction, this side. So I have last force that I got 0, right? So as we reach this point C, UDL has traveled for a distance of 3 meter. So minus the intensity of UDL is 3 and its distance is 3. So 0 minus 9 will come equal to minus 9 kilonewton. Next, force at C and to the right hand side of C. Last force that we got is minus 9 kilonewton. Now right at this point C, we have a reaction RC, which is coming from bottom to top. So the force that is going from bottom to top, we take it positive. So plus RC was equal to 11 kilonewton plus 11, this will come equal to 2 kilonewton. Okay, now let us find force at D. Now force at D should come equal to 2 kilonewton. So force at D equals to, last force that we got is 2 kilonewton, right? And is there any force in between C and D? There is no force acting in between C and D. So the force at D is equals to 2 kilonewton, which is exactly the force acting at D point. So our calculation is right. Now let us draw the shear force diagram. Okay, now at A I have minus 2, so minus 2 kilonewton. Below this line is minus, so even till B, to the left hand side of B, it is minus 2, right? And to the, when it is moving to the right hand side direction, यहाँ पर पहुंचकर the force is becoming plus 9. So here I have plus 9, so 9 kilonewton. Let's join this line. Okay, now force at E point, this point, it is becoming 0 here, right? So I have 0 here, and again when it is moving towards the right hand side direction, still it is 0. Now as it is moving to the C, this point, C point, to the left hand side of C, it is coming to -9. So let me mark it somewhere around here. Now let me join these 3 points, 0 and then to 9, -9. Okay, so this one here is 9 kilonewton. And then from C, when it is moving towards the right hand side direction, this side, though it is first becoming positive here, so it is going to +2 here. I join the line, and then from C till D it is remaining constant, which is 2 kilonewton. So from here to here 2 kilonewton, and it is constant. So this is my positive, and here I have 2 kilonewton. This is negative, positive and negative. Let me shade it. Okay, so this is the point of contraflexure. I'm sorry, not a contraflexure. This is a point of contra shear. This is a point of contra shear, and here at this point the bending moment will be maximum. Okay, so now for this question we don't need to find the point of contra shear, because we exactly know that at E point the distance from B to E is, this distance is exactly 3 meters. So we don't need to find. So the point of contra shear is located at a distance of 3 meters from B. Okay, now let's find a bending moment. Number 3, bending moment calculation. Right, now for a overhanging beam moment. Now see here, this is a typical question. So in here what is happening, point B, even though it is simply supported here, because there is a load acting at this point, so this portion here will act as a overhanging beam. So C to D also it will act as a overhanging. So we have at point B, it will not be equal to 0. The force will not be, moment will not be equal to 0. So moment at A point, where there is no support here, where it is free end, moment at A will be equal to 0, and D point here. So this is also a free point, so moment at D will also be equal to 0. Now let us find moment at C. I'm going in this direction at a right hand side. This is my right hand side portion, so I'm going in this direction, and in a cantilever beam when we go in this direction, it is a clockwise direction is negative. So moment at C is equals to minus, clockwise direction is minus in cantilever, so -2 into the distance is 1. So I have -2 kilonewton meter. Right, now similarly, if I want to find moment about this point B, moment at B, my moment at B will be equal to, this force here will go in this direction, which is a anti-clockwise direction. So in a simply supported beam to the left hand side, simply supported beam पे anti-clockwise is a negative sign. So -2 into distance till B is 1 meter, 1. So I have -2 kilonewton meter. This is to the right hand side direction, and this is to the left hand side direction. Okay, so right hand side पे cantilever लिया है, left hand side पे we have taken it as a simply supported. So let us find moment at this point E. So moment at E will be equal to, at this point will be equal to, we go from all the way from here till here. So this will be going in an anti-clockwise direction. This reaction RB will be going in a clockwise direction, and this force 3 kN per meter will be going in an anti-clockwise direction, right? So I have -2 into the distance from A till E is 4 meter, and then I have B, reaction at B, RB, going in a clockwise direction. So I have plus RB was, reaction at B was equals to 11 into the distance from B till E is 3 meter, right? Then I have a 3 kN per meter UDL going in a anti-clockwise direction. So -3 into the distance is 3 into 3 by 2. So from here you will be getting moment at E exactly equal to 11.5 kN meter. Okay, now let's draw the bending moment diagram. Okay, so moment at C, this point it is coming equal to -2. -2 here, 2 kN meter. Moment at B, which is towards this point, B point is this point, here also it is coming -2, so -2 kN meter. And moment at E, this point it is maximum, since this is a point of contra shear, so here contra shear will have maximum bending moment, and it's coming equal to 11.5 kN meter. Now let us join the lines. Moment at A and moment at D is 0, 0. So let's join it. Right now from here, since यहाँ पर पूरा UDL लग रहा है, तो it will go in a parabolic manner. Okay, from here and then join it down there. Okay. And from here we will be going to 0. So this is minus and this is in minus, this is plus. So this is your bending moment diagram. I hope this numerical is clear. Let us solve the second numerical for today's session. So again, for this numerical here, the diagram of the overhanging beam is given, and this time the type of loading is in a little different manner. So let us see how we can find bending moment and shear force diagram for such kind of overhanging beam. Let us start by finding its reaction. Reactions. So I'll have reaction at this point RA and reaction at this point RB. So RA plus RB will be equal to total load on the beam 5 plus 8 plus 4. So RA plus RB will be equal to 17 kilonewton. Okay, now summation of moment about A equals to 0. I'm taking it from this point. So this load towards A will go in this direction, 8 kilonewton will go in this direction, RB will go anti-clockwise, force at C will go in this clockwise direction. So let us say what we'll get. RA into 0 plus clockwise direction 5 kilonewton, so 5 into the distance from D to A is 2, plus 8 into distance from E to A is 3 now, minus RB into distance from B to A is now 5 meter. Next I have 4 kilonewton load going in a clockwise direction, so 4 into the total distance is now 6. This will be coming equal to 0. Now if you solve this, 10 plus 24, 8 3 24, 4 6 24 equals to, I'm sending this minus RB to right hand side, so it will become 5 RB. Now total of this will come 58 equals to 5 RB. From here RB will be equal to 58 divided by 5, which will come equal to 11.6 kilonewton. Okay, now from here RA will be equal to 17 minus 11.6 equals to 5.4 kilonewton. So we found RA and RB. Now let's find shear force. Shear force calculation. Right? So force at A, at this point I have only reaction RA, so force at A will be RA, which is equals to 5.4 kilonewton. Now force at D and to the left hand side of D का left hand side, इधर last force कितना मिला था 5.4, so 5.4. Is there any force in between A and D? There is no force in between A and D, so it will be 5.4 kilonewton only. Next, force at D, right hand side of D. Now we go to right hand side. So last force that we got is 5.4. Now there is exactly 5 kilonewton load acting on top of D, जो हम right hand side direction पे consider करेंगे. So 5.4 minus 5 will give you exactly 0.4 kilonewton. Next, let us find force at E and to the left hand side of E. Force at E, left hand side of E. Last force that we got is 0.4 kilonewton. Now is there any force in between D and E? There is no force in between D and E, so it will remain 0.4 kilonewton only. Similarly, force at E, right hand side of E. Now right hand side, this side. Last force that we got is 0.4 kilonewton. Now on top of E we have exactly 8 kilonewton load. अब ये 8 kilonewton load जो E पे लग रहा है वो हम right hand side पे लेके जाएंगे. So हम यहाँ पर addition करेंगे और ये ऊपर से नीचे आ रहा है तो it is -8. So this will be coming equal to -7.6 kilonewton. Okay. Now similarly force at B and to the left hand side of B. Left hand side of B. Last force that we got is -7.6 kilonewton. Is there any force in between E and B? There is no force, so it will remain 7.6 kilonewton only. Force at B, right hand side of B. ये direction पे B का. Last force that we got is -7.6. Now B पे RB reaction वहाँ पर support है तो we need to take the reaction RB, which is coming from bottom to top, right? So bottom to top we take it plus. So plus RB that we got is 11.6. RB here is 11.6. So this will come equal to exactly, it will come equal to 4 kilonewton. Now let us find force at C point, this point. What is the last force that we got? It is 4 kilonewton. Is there any force in between B and C? There is no force in between B and C, so this is the last force, and this force is exactly equal to the point load coming at this free end C. So our calculation is right. Now let us draw the shear force diagram. Right, so at A I have 5.4 kilonewton. So towards D also I have 5.4 5.4 kilonewton. Let's join the line, right? And now towards the D, when it is going to the left hand side direction, it is decreasing and becoming 0.4. So it is becoming 0.4 here, 0.4 kilonewton. Let's join the line. And towards the E again, E tak it is remaining 0.4. So constant it is going 0.4. Then towards, when it is going to the right hand side direction, it is going to minus. So I have minus 7.6. So this is 7.6 kilonewton. And towards B, till B it is remaining constant, minus 7.6. Then again to this point, B point, when it is going to the right hand side, it is going to positive. So it is going to positive 4. So let's join the line, right? And this is 4 kilonewton, and it is remaining constant till C. So constant till C, and here. So this is my positive, negative, and positive. Let's shade it. So this is the shear force diagram. Now let's find the bending moment. 3. Bending moment calculation. Now for this case, at support and free end it will be 0. So moment at A will be equal to 0, and moment at C will also be equal to 0. Now let's find moment at this B point. Now BC point will be acting as a cantilever. So moment at B will be equal to, I'll be calculating it in a cantilever manner. So this force 4 kilonewton will go in a clockwise direction towards B, और cantilever पे clockwise is minus. So minus 4, B से C तक distance कितना है 1 meter into 1. So this will become equal to minus 4 kilonewton meter. Now let's find moment at D point. Moment at D will be equal to, I go from this point A till D. So the reaction, RA reaction towards D will be going in this direction, which is clockwise. So RA was equal to 5.4 and the distance is 2. So I have 10.8 kilonewton meter. Similarly, moment at E, this point, अब यहाँ से यहाँ तक जाते हैं तो 1 is RA reaction going towards E, then I have point load at D going towards E. So this will go in anti-clockwise direction. So I have reaction RA into the total distance is 3 meter now, minus point load going in the anti-clockwise direction. So minus 5 into the distance is 1. So this will become equal to 11.2 kilonewton meter. Now let's draw the shear force diagram. Okay, so at A and C it is 0, at B it is coming minus 4 kilonewton meter, at D this point it is coming 10.8, so I'll mark it here, 10.8 kilonewton meter. E point पे it is coming maximum 11.2 kilonewton meter. Now since there is no UDL acting in this beam, it is all point loads, so when you draw this bending moment diagram, it will be a straight line. So just connect it straight, then increasing, then it will go to negative here, then from here it will go to 0. This is negative here, this is positive. Okay, so you can even find this distance I'll leave it up to you to find this distance x, and this point here is a point of contraflexure, so you can find this distance x by yourself. And this is the bending moment diagram. So this is the last numerical for today's session, and this is also the last numerical for the case of overhanging beam. So let us start. Draw SFD and BMD indicating all the values at important points. Refer the figure given below. So this is the diagram of an overhanging beam, and for this we need to draw SFD and BMD. And after we find SFD and BMD, we need to put all the important values in the diagram. So let us get started. Let us start by finding its reactions. So here for this numerical, I'll have reactions at A, support A and B. So I'll have it here RA and here RB. So RA plus RB will be equal to total load on the beam. Total load on the beam is 1000 Newton. First load, second load 2400 Newton plus 1500 Newton. So this will give RA plus RB will be equal to 4900 Newton. So summation of moment about A will be equal to 0. I'm taking it at this point, so this force will go in a anti-clockwise direction. So I have first of all 1000 into minus 1000 into its distance is 2 meter. Then RA into 0 since starting point is here. Next I have 2400 Newton load going in this direction, RB in this direction, and 1500 Newton load going in clockwise direction. So plus 2400 into distance from C to A is 4 meter minus RB into distance from B to A is 7 meter plus, since it is going in a clockwise direction, 1500 into distance from E till A is 7 meter. No, not 4, 5, 6, 7, 8, 9, 10, 11 meter. I'm sorry, it is 10 meter, okay? So it is like 4, 5, 6, 7, 8, 9, 10. So 10 meter goes to 0. So from here we'll be getting minus 2000 plus, it will be 0 this one, so this one will be equal to 9600 plus 1500 into 10 is 15000 equals to, I'm sending this to right hand side direction, so it will be plus RB into 7. So adding all this together, I'll be getting equal to 22,600 equals to 7 RB. So from here RB will be equal to 22,600 divided by 7 will be coming equal to 3,228.57 Newton. So I have RB RA will be equal to 4,900 minus 3,228.57, which will be coming equal to 1,671.43 Newton. Now let's find the shear force. So first of all, I have at this point shear force at D. Shear force at D will be equal to, it is coming from top to bottom, so minus 1000 Newton directly. Okay, so this will be going constant till A force at A and to the left hand side it will be constant. Here also I'll have 1000 minus 1000 Newton. Now force at A, right hand side of A. Okay, at A and right hand side of A. So the last force that we got is minus 1000. Now at A I have reaction RA coming from bottom to top. So if it is coming from bottom to top, it is plus RA. And how much is RA? 1671.43. This will give 671.43 Newton. Similarly, force at C and to the left hand side of C will be equal to, last force that I got is 671.43 Newton, and since there is no force in between A and C, it will remain 671.43 only. Now force at C, right hand side of C, this side, so 671.43, and there is a 2400 Newton acting right on top of C, so I take this at right hand side, so minus 2400. This will be giving you force equal to 1000 minus 1728.57 Newton. Okay, now similarly force at B and left hand side of B will be same again. Since there is no force in between C and B, it will remain same, which is equal to 1728.57 Newton. Now force at right hand side of B will be equal to force at B and right hand side of B will be equal to, last force that we got is minus 1728.57. Now as you can see, at this B point there is a reaction RB, which is support. So this support reaction will be coming, since it is coming from bottom to top, it will be positive. So I have plus RB. RB is equals to 3228.57. This will come equal to 1500 Newton. Okay, now similarly force at E. Since there is no force in between B and E, the last force that I got is 1500 Newton. So this 1500 Newton is exactly the load coming at this E point. So our calculation is right. Now looking at this, let us draw the shear force diagram. Right, now force at D, it is minus 1000, 1000, 1000, and it is constant till A, right? Constant till A, left hand side of A. So here I have 1000 Newton, and when it is going to the right hand side, aka right hand side jar hai, to it is becoming positive. So I have 671 here, and this 671 C के left hand side तक constant है, constant till C and left hand side of C, 671.43 Newton. Now when it is going to the right hand side of C, it is decreasing and going to 1000 minus 1728. So let me mark it here. This is 1728.57 Newton. Okay, and from here it is remaining constant till B point, and from here it is suddenly increasing and going to 1500 when it is going to right hand side of B. So it is 1500 at B point, right? And it is remaining constant till E point. So this is 1500 Newton, and this is positive, negative, positive, and negative. Let's shade it. So this is my shear force diagram. Now let's find bending moment. Number 3, bending moment calculation. So for this overhanging beam at supports, this support, there is support A and support B. The moments here will not be zero. There is a free end here which is D point, so moment at D will be equal to 0, free end, and we have another free end at this point E, so moment at E will also be equal to 0. Now moment at B here, B and E will be acting as a cantilever, so I'll go from this direction to, from here E to B in this direction, so this force will go in a clockwise direction, and in cantilever beam clockwise is a negative sign, right, negative moment. So M moment at B will be equal to minus 1500 into the distance from E to B is 3 meters, so this will give you equal to minus 4500 kilonewton meter. Now similarly, let's find moment at this point, A point. So moment at A, now I'm going from left to right, okay, and I'm considering it to be a simply supported. Now here this force towards A will go in this direction, clockwise direction. So clockwise direction from the left hand side will be taking it as a negative, okay, so it will be negative 1000 into the distance from D to A is 2 meters, so it will be coming minus 2000 kilonewton meter. Now let's find moment at this point C. Now I'll go from left to right, so this force will be going in a clockwise direction, anti-clockwise direction, this will be going in a clockwise direction, so moment at C will be equal to minus 1000 into, now from D से लेकर C तक distance is 4 plus 2, 6 plus reaction RA reaction, which is equal to 1671.43 into, now distance from A to C is 4 meter, so into 4, this will be coming equal to 685.72 kilonewton meter. So this is the moment. Now let us draw the diagram. Right, so at this point D and at C it will be 0, and at moment at B it is coming minus 4500 Newton. It's not kilonewton, I'm sorry, here it's all Newton meter. Force, since force is given in Newton, bending moment will come in Newton dot meter, okay, so I have Newton 4500 Newton dot meter, and then next at moment at A I have minus 2000, so this point moment at A minus 2000, so 2000 Newton dot meter, and moment at C point, this point I have 685, this point 685.72 Newton dot meter. Now let's join. Since there is no UDL, all are point loads, so we can draw a straight line, straight from here, straight, and then from here straight, and then here. So this is negative, negative and positive. So this is the bending moment diagram.